Hello guys, my name is Godlove Appiah and I am a graduate student in the Department of Mathematics and Statistics, and I'm here to give a brief lecture on the basic introduction to R. And also this lecture actually is targeted to uh, students who do not have any in-depth knowledge in the R software package. So, so this lecture is just about a basic introduction to the R environment. So for those of you who do not know what R is or who do not have any experience in the R language, so today we're going to learn some few stuff about R and how we can go about certain how we can go about a few stuff in R. So this is the outline for today's lecture. So we're going to look at what variables are. We're going to also look at some various kinds of data types that are accepted or allowed in the R environment. And also we're going to look at certain operators that can be used in R. And also we're going to look at certain conditional statements that are used in R, and also we're going to look at loops, which is very fundamental in programming, in any programming language, not just R. So loops is actually the foundation of every programming language. So we're going to look at what loops are and the various kinds of loops and see how we can implement them in R. And also we're going to look at strings, which are just characters, and how we can implement those characters in R. And also lastly but not least, we're going to look at functions that can be used in R as well. So to begin with, we're going to look at variables. What do we mean by a variable? Or what are variables as far as the R software package is concerned? A variable or variables are just reserved memory locations to store values. So this means that when you create a variable, you actually reserve some space in memory. So for instance, I have this variable x which I created, and to that variable I assign this character here, hello. So this means in R I have just created or reserved some memory location where I store this character hello to this variable x. So when we go to so this is the R environment. This is how the R software looks like. So this is actually R Studio. So in order to get this R Studio running on your laptop or your computer, you first of all have to install the traditional R. So once you install the traditional R, you now can download from Google the R Studio. You can also download the traditional R from Google. So once you have the traditional R software installed, you can now run the R Studio on your laptop. And this is the R Studio environment. This is my command file here, right over here. This is where my codes or my programs are created on this window right here. And over here I have the global environment where every variable that is created on this window here is recorded here. For instance, I have variables, three variables created. These variables were created on this window, and they have been recorded right here. And also I have the console window right here where you obtain the results of every code that is being run. So in other words, you obtain your output from running your codes on this window on the console right here. So I was talking about a variable. So what I want to do, I want to create a variable x to which I assign a character hello. So once I run this code, what I did is I reserved some memory in R where I store this character hello into this variable x. So at any point in time along programming, you can call in this variable x, and this variable would reproduce or would bring out the value that is stored into that variable. So if I just type in x right here and I run that, I should have, as you can all see here, I have the output right here. So I have the variable x, and this gave me what I stored into that variable, which is hello. So that is basically what we mean by variables in R. So the next thing that we're going to consider are data types. Data types are very important when it comes to programming, and especially in the R programming language. So what do we mean by data type? So a data type in programming in general is a classification that specifies which type of value a variable has and what type of mathematical, relational, or logical operations can be applied to it without causing any error. So that is basically what we mean by a data type. And there are basically 5 classes of data types. So we're going to look at each of these data types and see how these data types can be implemented in the R software package. So the first class of data type we're going to consider is a vector. I believe we are all familiar with the concept of vectors. So what is a vector? A vector is just a sequence of data elements of the same basic type. There are 5 atomic vectors, also termed as 5 classes of vectors in R. So R considers 5 classes of vectors, which we're going to look at. So the first class of vectors is logical. Vectors of which contains only a set of logical values, and by logical we mean true, either true or false. And also the second class is the class of integers. We also, when we talk about integers, we're just referring to exact whole numbers, and we have some examples here. So in R, when you enter in integers, you need to include this L, which means that you're telling R that this value you're entering should be considered as an integer. In other words, as an exact whole number. And the other class of vectors is vectors of numeric values. So here, numeric values consist of numbers, which it could be exact whole numbers or it could be decimal points. So those are a set of numeric. That is a class of vector called numeric. And then we also have this the vectors of complex, in a vector of complex numbers, which we have some examples right here. And we also have the last class of vectors, which is a vector of characters. So we got some examples right here. So let's look at this individually and see how we can implement this in R. So let's see how we can implement this in R. So what I would do is to list down these various kinds of vectors and identify their classes in R. So the first thing we're going to look at, so I'm going to say, so to write comments in the R environment, you need to precede those comments by a hashtag. So with this hashtag, and you can comment these as vectors. So, and you also close that with a hashtag as well. So what I'm going to do, so what I'm going to start with the first class, which is logical. I'm going to create this variable vtr1 to be equal to C. Like I said, logical vectors consist of true or false. So it's either the statement is true or is false. So I have true and then false. So I'm going to run this code here. As you can see, I have it here already. This variable was created. As you can see on the global environment window, I have the variable vtr1 created. So what I would do, I would like to verify the class of this vector. vtr1. So once I run that, I can see the class of this vector right here as logical. So this tells me that the vector that I have entered in R is a logical vector. So, and depending on the type of analysis you're dealing with in R, you will know what kind of vector you need to use. So the next thing we're going to consider is the numeric vector. Numeric vector. So I'm going to create another variable, vtr2, and to it I combine this set of values, 15, 85.67, 85.67, 4954, 4954, and then I have 99999. Yeah. So what I'm going to do, I'm going to run this, and I've successfully created that vector. So I now proceed to check in the class of this vector, vtr2. So, and again, R tells me that the class of that vector is numeric, which is the second class of vector. So the next class of vector we're going to consider is integer. So what I'm going to do is to create another variable vtr3, and to it and assign, I combine a set of integers 35L. Like I said, we use L to let R know that you want to work with only integers. So I bring comma, I have 58L, then I have 146L. So once you do that, let's create this variable, and we have successfully done that. So check the class of that variable, of that vector vtr3. As you can see, I have the class here indicated as integer. So the next thing we're going to consider, so one thing that we need to note, like I said, a vector is a sequence of numbers of one specific type. So let me try and combine a vector, create a vector with different classes containing different classes in one particular vector. So let me say vtr create another variable vtr5 is equal to C. I have true 35L 3.14. So here you can see that this vector here has a logical value. It has an integer and it has a numeric value. So let's try and create this vector, and let's see what this vector is going to give us. So let's call the value of that vector vtr5. So you can see that the vector vtr5 has retained only numeric values, but when I was creating it, I entered three different kinds of values, which are numeric, integer, and logical, but it only gave me numeric values. So this simply tells us that in R, whenever you create a vector which consists of values of different types, it will only record the vector in terms of one specific type of value that we have. So here it considered the vector as a numeric vector. That is why we have values here to be numeric. So if we check the class of this vector, we're going to have it as a numeric vtr5. So the class is going to be numeric, as you can all see. So that is how, this is one important thing we need to know, that when you combine different values of different types in one vector, it only retains one particular type. So let me have another one here. vtr6 is equal to C. Then I have hello. I have false. I got a 65 error. So in this vector here, I combine again values of different types. I have a character here, I have false here, and I have I have a logical value here, and I have an integer right here. So let's run this and see what happens. So what it So as I was saying, so I had an error. That was because the first was in lowercase, so I had to make it uppercase. So now we're good. We can continue. So like I was saying, when you create a vector with different data types in R, what R does is that it converts the entries of that vector into a common data type. So in this example, the entries were converted into numeric data type. So here, let's see, VTR6. So I have class VTR6. So here, another important thing we need to notice, if you create a vector in R where you combine a character with the various types of data, with the various data types, automatically R will convert all entries into character. We'll treat all entries in that vector as a character. So here you can see the class of this vector to be character, but I entered a character here with a logical data type and an integer data type, but everything was converted into a character. So here it would not necessarily convert it into a common data type, but only to a character, because you have a character as an entry in that vector. So here we didn't have any character, so we have three different data types, that is a logical, integer, and numeric. So it had to convert it to a common data type of its choice, and that was numeric. So that would be about the vectors. So the next class of data type we're going to consider is matrix. Yeah. So what are matrices? Matrices are just objects in which the elements are arranged in a two-dimensional rectangular layout. And how to enter a matrix in R, this is a syntax that is always used. So yes, you create your matrix, you have your data, your number of rows, your number of columns, your rows, and then the dimension names. So your data simply is the input vector, which becomes the data element of the matrix. And this is your n row is the number of rows to be created, and your n col is the number of columns to be created. And the dim name is the name assigned to the rows and columns. So what we're going to do, we're going to see how we can create a matrix in R. So let's quickly do that. So I'm going to proceed to matrix. So I'm going to create a matrix. Empty R is equal to matrix, and then I have a combined 5. So what I'm telling R is that I'm telling R create a matrix between the which will have entries ranging from 5 through to 29. And in that matrix, I want to have 5 rows and 5 columns. So this is going to be my matrix. I'm telling R to create a matrix consisting of numbers ranging from 5 through to 29, where I have 5 rows and 5 columns in that matrix. In other words, I'm telling R to create a 5 by 5 matrix ranging where the entries of that matrix will range between 5 and 29. So let's run this line of code, and I have successfully created that matrix. So to view the entries of that matrix, you just have to call the variable mtr, and then you run it, and you will see the result in the console window right here. So I have here 5 through to 29, and it's a 5 by 5 matrix. So that is basically how a matrix is created in R. So the next thing we're going to consider is arrays. Which is another class of data types. So array, they are just data objects which can store data in more than 2 dimensions. So in other words, an array is just an improved version of a matrix, if I may say so. So it's a matrix in a higher dimension. So in matrix, you are only looking at a 2 dimension, but in an array, we're looking at more than 2 dimensions. So, and this is a syntax for creating an array in R. So you have the data, the dimension, and the dimension names. So let's quickly look at how we can create an array in R. So I'm going to create a variable called ARR, and then I want to assign an array to that variable. So I'm going to have array, and then I have 1 through to 9, and then I have the dimension to be equal to 3 by 3. Then 4. So here I have a 4-dimensional array that I'm going to create consisting of values between 1 through to 9. So I'm going to run this array. I've successfully run the code, so I'm going to call that array and see how it looks like. So this is my array that has been created. So that is how an array looks like. So the next data type we're going to consider is lists. For lists, they are R objects which contain elements of different types, like numbers, strings, vectors, and another list inside it. So here, actually, I said earlier that we cannot create a vector which consists of entries of different types. But in a list, you can have entries of different types. So you can have a list which consists of logical, numeric, integer, complex numbers, and so on and so forth. And this is a syntax for creating a list in R. So what I'm going to do, I'm going to create a list which consists of the vectors that I've already created, which consists of VTR1, VTR2, and VTR3. So I'm going to create that list. Let's look at how we can easily create a list in R. So I have my list is equal to list, then I have VTR1, VTR2, and VTR3. So I'm going to run this code. I have successfully run that code, and then I want to view the content of my lists. I just run it, and I have this as the content. This is the element, the entries of VTR1, VTR2, and VTR3. So this was listed together as a list. So the next data type we're going to consider is the data frame. And this is actually what we widely use in data analysis. In any programming language, we actually deal with data frames. So a data frame is just a table or a two-dimensional array with a structure in which each column contains values of one variable and each row contains one set of values from each column. And this is a syntax for creating a data frame in R. So what I'm going to do, and also we need to note that there are inbuilt data frames that can be found in R, and you can also create your own data frames. So let's look at how we can create our own data frames, and we're also going to look at some inbuilt data frames that are already in R. So we're going to quickly look at data frames. So I'm going to create a variable D1 to be equal to consists of numbers between 1 and 5. And then I'm going to also create another variable D2, which consists of a list of names. I'll say Neil. I'll say Jude. I'll say Adam. Adam. And I'll say James. These are just random names. And then I'll say John. And then I'm going to create another variable D3, which consists of this set of numbers: 15, 25, 65, 145, and 74. So what I'm going to do is to create a data frame out of these three variables. So I want to have these three variables in a tabular form. That is what I mean by data frame, where in that table I have a number of columns and a number of rows, where the columns would denote the variables and then the number of rows will denote the observations, in other words, the entries in these variables that I've created. So I'm going to create this. Excuse me, there's an error here. All right. So I'm going to run this again. That's it. And then I run that as well. I think there's an error here as well. Fix that. All right. Then you run it again. Okay. And then I run this as well. So I've successfully created those 3 variables. So what I want to do is to create a data frame with these 3 variables, D1, D2, and D3. So I'm going to run this. And as you can see in my console, I have this result. I have D1 my first column, D2 my second column, and D3 my third column. And I have these observations, which are the entries of each of those variables. So this makes our data very easy to work with, especially in data analysis. So it's very important to convert every data type that you have into this data type so that you can easily work with it in the R environment. So let's look at some inbuilt data frames in R. So some inbuilt frame, we have data.frame air quality. So I run this and I have this data frame. This is already in R. As you can see, it has 1, 2, 3, 4, 5, and 6. It has 6 columns, and the rows are just the entries of each of those variables. So that is an inbuilt data frame in R. So the next thing we're going to consider is data frame, is operators. So we're going to look at certain operators that can be used in R and how we can use them. So what are operators? They are just constructs which can manipulate the value of operands. The following are the types of operators in R that are widely used in R. We have the addition operator, the subtraction, which are all familiar with, the multiplication operator, the division operator. We have the modulus operator, the exponent operator, and the floor division. So we're going to look at these 2 modulus and floor division operators in R. And I assume and I believe that the other operators you are all familiar with. And as you can see, we can just use this. These are the syntaxes. The syntax you can use in R to implement those operators. So what we're going to do, we're going to look at this modulus and the floor division in R. What are they actually, and how we can use them in our analysis. So we're going to first consider modulus, the modulus operator. So what does the modulus do? So first of all, I'm going to have the normal division. I'm going to have 22 divided by 7. So I want to print that. I have 3.142857. That is just the pi constant. So this is the normal division that we all know. So I want to make use of the modulus division. So I'm going to have print, and then I have 22, and then the percentage sign twice, and then 7. So what the modulus operator does is that after dividing, it only retains or gives you the remainder of the division. That is what it does. So if I divide 22 divided by 7, I am going to have a remainder of 1, because 7 can divide 21 exactly, but you're going to have 1 here. As you can see, the printout is 1. The result of that modulus division, I have 1, which is just the remainder of dividing 22 by 7. So that is the purpose of modulus division. It just gives you out the remainder of the division. And then the next kind, which is the floor division. So what the floor division does is that it rounds the division to the previous whole number, regardless of whether the decimal point is below or above 5. It only rounds it to the previous whole number. So this is how it looks like. So let's look at the floor division. (22), the percent, and then the division sign, and then percent again, and that's 7. So here we run this. I have 3. So the actual division, I had 3.14. So this rounded this number to the previous whole number, which is 3. All right. So it doesn't matter whether the decimal point here is above 5 or below 5. It only gives you the previous whole number. It does not round it to the nearest whole number. It rounds it to the previous whole number, which is 3 in this case. So that is the purpose of floor division. So now we're going to look at some relational. So like I said, we are looking at operators, and there are various types of operators that are used in R. We just looked at 2 of arithmetic operators, which I believe some of us might not be familiar with, and how we can implement them in R. So the next type of operator we're going to look at the relational operator, and there are six main relational operators that we need to look at. This is the equal to. So this is how we implement this in R. So we need to say double equal to when we are implementing the equal to in R. Just the one equal to is not a relational operator. It's just an assignment operator. It assigns a value to a variable. So we have the not equal to, and that is how it is implemented in R. The greater than and the less than, which we are all familiar with. The greater than or equal to, and the less than or equal to. So we know the next operator we're going to look at is the assignment operator. There are 2 types of assignment operators. The left assignment operators, which is these are examples of the left assignment operator. X is equal to 5, and x is less than or equal to 15. this is actually, yeah, this is the left assignment operator, and then the right assignment operators. We have 20 coming before the x, and then 25 in. So we just reverse the way that the code is ended. So that's the difference between the right and the left assignment operators. So the next type of operator we're going to look at is the logical operators. And there are three kinds of logical operators: the AND, the NOT, and the OR. So we're going to look at what each of these logical operators does. So the AND, which is implemented using the ampersand in R, it combines each element of vectors and gives an output true if both elements are true. The OR operator, which is using this sign to implement in R, the OR combines each element of the vectors and gives an output true if one of the element is true. So the OR, we just need one element or one entry in the vector to be true, and it will give us an output of true. But with the AND, we need all elements of all entries in the vector to be true in order to get an output of true. But the NOT logical operator takes each element of the vector and gives the opposite logical value. So let's look at how we can implement this in R. Let's quickly look at how we can do this in R. So what I'm going to do is to create some variables. So I'm looking at logical operators. So I'm going to create variables. The value 1 is equal to true, false, true, and false. And I'll create another value 2, which is equal to false, true, true, false. So here I have two variables that have been created, value 1 and value 2, and I have these entries in each of these variables. So I'm going to look at the three kinds of the logical operators and see how they relate. So I'm going to begin with the AND logical operator. So I want to print value 1 and value 2. So first of all, I need to run these variables to create them. Yeah. So like I said, the AND operator, what it does is only gives an output of true if both entries in the vectors are true. So here the first entries, I have true, false. I have false, true here, true, true, false, false. So what I expect to see is I expect here to be false because both entries are not true here as well. But these two I expect true and false respectively because both entries are true, true, and false, false respectively. So let me quickly run this and see what Okay, I think I have an error here, so let me fix it. So that should be good to go. All right, so I have false for the first entry. Like I said, that's exactly what I was expecting, and false here, and true and false as well. So, like I said, both statements have to be true for in order to have a true output for the end logical operator. Then let's look at the OR. I have this, yeah, value 2. Here I gotta put value 1, yeah. So here, one of the statements, one of the entries, only once has to be true in order to retain a true output. So here I have true, so that's why I have true here. Here I have one of them to be true, I have both to be true, and I have both to be false. So since I have both to be false, I should have a false here as in the output. And then I'm going to use the not print value 1. So here I'm telling R to give me the exact opposite of these entries in this variable value 1. So true will tend to false, false will tend to true, true will tend to false, and false will tend to true, in that order. So that is what we mean by the opposite, this logical operator here. So I have false, true, as expected. So that is it about the logical operators. So the next thing we're going to consider is the conditional statements. We also need to look at this conditional statement. There are mainly 4 types of conditional statement that we will look at. The first is the if statement. The if statement checks a specific condition, and if the condition is found to be true, then it goes on to execute a set of statements. But if it is not, it will ignore this set of statements and move forward. So what I'm going to do is, I also have the else if statement. The else if statement, this is used to check multiple statements and check the corresponding validity. And the else statement, which is the third type of conditional statement, is a conditional statement that definitely gets executed if no other condition is met. And then I have the switch case statement. Here, you are already aware of the value the expression is going to take. You need to specify the actual value that expression can take and not uncertain values. So we're going to look at how we can implement these state conditional statements in R. So we're going to start with the if statement. So I'm going to create some variables. var1 is equal to 25, and then I have variable 2 is equal to 35. So here I'm going to tell R if var1 plus var2 is greater than 50. Then I'm telling R to print value is greater than 50. So, like I said, the if conditional statement checks a specific condition, and if that condition is found to be true, then it goes on to execute it, and if it is not, it will ignore that condition. So here I have two variables, 1 and 2, 35, 25, and 35. So I'm telling I want to add these two variables, and if the sum is greater than 50, then I should print this output. So I would first to go and check whether this sum is indeed greater than 50, and if it is, then this will be printed. If it is not, it's going to ignore it. So here, obviously, this sum is greater than 50. So I'm going to have to run these codes. Let's see what we have. And that was printed, as you can see on the console. It was printed because the if statement, it had to check the validity. So it checked and it found out that this sum is indeed greater than 50. That was why I have this output. So if I change this 50, let's say to let's say 75. So we all know that this sum is less than 75. So I expect R to ignore this condition because the condition is not actually true. So let me run it and see what comes out. You see, I don't have any output. So that was simply ignored because it was checked and found out that the sum is actually less than 75. So that is it about the if conditional statement. Then the next we're going to consider is the else if statement. Like I said, this is used to check multiple statements and check the corresponding validity. So here I'm going to have else if variable var1 plus var2 is greater than 50. Then I'm telling R to print I'm gonna copy this and paste it right here. And I'm change this guy to 50. So what the else if does, let's look at it again. It is used to check the validity of multiple statements. So let's run this. let me say 50 right here, 50 right here, and here 100. We have else if one plus two greater than 25. Then I'm gonna have this and just copy this and paste it right here. I copy this whole. I'm gonna comment this guy here. I keep having some errors here, so let me take out this. So here, what I will basically do is it's going to run let me see. I'm gonna actually do this. I'm gonna clean this and then get rid of this. So here, what I will basically do is going to run this if the first statement, which is says that if the sum is greater than 100, then it should print this. Obviously, this is actually wrong. It's going to ignore that and proceed to the next statement, which is also again not correct, and proceed to the next statement, and then actually it's going to print out the last statement here because that is the actually correct statement with the correct condition. So it will check the validity of these other statements and conditions and ignore if it is false and then proceed to execute if it is correct. So that is what R basically will do with the else if conditional statement. So here, write this. So here I have the else conditional statement, which will definitely print out this apple right here. So that is it about the conditional statements. So the next thing we're going to look at is the loops, which I said earlier, the most important concept in programming. The loops allows you to execute a statement or group of statements multiple times. This reduces code redundancy and makes the performance of the program better. So, and there are three types of loops. The repeat loop. This repeats a statement or group of statements while a given condition is true. it tests the condition after executing the loop body. While loop repeats a statement or group of statements while a given condition is true. It tests the condition before executing the loop body. And the for loop, which is the most widely used loop in programming, this repeats a statement or group of statements for a fixed number of times. It tests the condition before executing the loop body. So let's look at the repeat loop, at an example how we can implement the repeat loop in R. So the repeat loop, we have I'm going to create a variable val 1 is equal to, let me say, val 3 is equal to 5. And I have repeat print for 1. Val 1 is equal to val 1 plus 2. If val 1, val 3 is greater than 21, then break. Is val 3. I'm gonna run this. I've successfully created a variable. Then I run this. So that is a repeat loop which is currently running, as you can all see. So what I did is I'm repeating this number 5 until the number of times until it's greater than. So I'm telling R to break the loop if the variable that I created is greater than 21. If the number of times it's going to repeat is greater than 21, then the loop is going to break. So it is still running, as you can all see. It is repeating the number 5, and until it gets to the point where it's greater than 21, then the repeat loop that I created is going to break. So as you can all see from the repeat loop right here, so this simply repeats. So the repeat loop repeats a statement while a given condition is true. So the next loop we're going to look at is the while loop. So the difference between the repeat and the while loop are kind of similar, but there's a slight difference between the two. The repeat loop tells a condition after executing the loop body, but the while loop tells a condition before executing the loop body. I'm going to copy this. So the while loop. So here is going to be y for 3 over 3 is less than 21. Point over 3. Point over 3. Is equal to over 3 plus 2. So this is an example of a while loop that I created. So the repeat loop is still running, as you can see. This running, the running time, this takes kind of a little bit of time to run. So this should actually because the repeat loop is still running, so we're gonna proceed to looking at the for loop. So with the for loop, we know the number of times we want a statement to be repeated. So that is a difference. If we repeat a statement a fixed number of times, so we already know. So with the for loop, so I have for x in 1 to 25. Point x. So here I'm telling R in this loop right here to print x for x actually 25 times. That is for x in 1 between 1 and 25. So I'm repeating this statement 25 times. So here I specify the number of times that I want the statement to be repeated. So that is the difference between these three kinds of loops: the repeat loop, the while loop, and the for loop. And like I said, they are the most wide, they are the foundation of every programming language. So the next thing we're going to look at is functions. A function is just a block of organized, reusable code that is used to perform a single related action. The following are various types of functions. So there are two kinds of functions: predefined functions, which are already defined in R. Example, the print function and the paste function. That this function that I use here, the print function, they are functions that are already defined in R. And we also have the user defined function, which are functions defined or specified by the programmer or the user. So this is where we're going to end today's lecture, and I'm going to let you guys have a list of recommended textbooks that you should use in order to further on your knowledge in the R programming language. Like I said, this was just a basic introduction to the R software to those who do not have any experience or in-depth knowledge into the R software. So you should look out for recommended textbooks and other material that you guys can consult in advancing your knowledge in this R software. And thank you all for your attention.